So this is a 7.1 practice. We're going to talk just about simplifying. Simplifying is not when you have an equation where it's something equals something and you have to prove that one side is the same as the other. Simplifying just means make smaller. So the first thing that you guys should do is you should have your identities at the top of your page. I will give you these identities on your quiz on Thursday, but it's important that you guys have them there so you can keep referring to them. So number 34, it says cosine x times tangent of x, all right? I put the times in the middle just so you guys could see it. It's just written together, but that means multiply. So our two most basic functions that we have in trig are sine and cosine. So I'm going to leave cosine x like it is. Just leave it as the cosine of x. What can I change tangent into? Look at your identity sheet. What can I change tangent into? Sine, good. Sine over cosine. I can write this the same as sine x over cosine of x. Would you guys agree that cosine of x is over 1? All right, so now what can I do to simplify? Cosine x on top crosses out with cosine x on bottom. So the simplified version of this is just the sine of x. Questions? No? Okay. All right, let's look at the next one, 36. I see secant squared of x, and I have 1 minus sine squared of x. Remember, when we have 1 minus or plus a trig function that is squared, we first look at our trig identities that are our Pythagorean identities, right? So you guys should be familiar with when you see 1 minus sine squared. What does 1 minus sine squared equal? Cosine. Yep, look, if I have, watch, I have our most basic trig identity, which we'll talk about a Pythagorean a million times. Sine squared x plus cosine squared x equals 1. If I subtract sine from both sides, 1 minus sine squared x equals cosine squared. So I'm going to replace 1 minus sine squared with cosine squared of x. Now look at our sheet. What is secant the same as? Good, 1 over cosine. So it's secant squared, so that means I'm going to put it as 1 over cosine squared of x. Questions? Anybody have any questions so far? We're good? Okay, so now what? What can I cross out? Cosine. Yep, cosine top, cosine at the bottom crosses out, and this is simplified as just the number 1. That's it. You guys see that? All right. Okay, so now we're going to scoot over. I have 38. It says secant over cosecant. Nothing squared, anything like that. So let's just look at our identities. What can I replace secant of theta with? What is secant the same as? 1 over cosine, okay? 1 over cosine. And again, we're trying to go to our most basic functions, which are sine and cosine. What can I replace cosecant with? 1 over sine, all right? So now you guys are like, well, that didn't really help me much. That doesn't look simplified. That looks even harder. Well, I have 1 over cosine, which is a fraction, and then I have 1 over sine, which is a fraction. What are we doing to those two fractions? We're dividing them. When you divide fractions, guys, what do? You multiply by reciprocal. You keep, change, flip. So this is the same as 1 over cosine theta. That stays the same. What do we change division to? Multiplication. And when I flip, 1 over sine becomes sine, good, over 1. So when I multiply those two together, I get sine times 1 is just sine of theta over cosine times 1 is cosine of theta. Guys, what is sine over cosine? Tangent. Very good. Very good. Do you see how this little puzzle can be picked apart and put back together? Yes? Okay, good. Good job. Scooting along. Okay, I have squareds here. Do I look for a Pythagorean identity for tangent squared or secant squared? I'm going to say no. Why? How come not? What is this tangent squared or the secant squared missing? It doesn't have a plus or minus 1. Good. So since it's just the trig function by itself, we'll just break it down using our identities. What is tangent the same as? Remind yourself again. Where's my chart? What's tangent the same as? Sine over cosine. You guys are getting better at that. Good. So I'm going to rewrite tangent as sine squared theta over cosine squared theta. Since it's squared, the squared just stays with it. Divided by, what's secant the same as? 1 over cosine squared theta. Now, guys, this is the same thing as the problem we just had before. This is a fraction divided by a what? So we keep, change, flip. Good. So I have sine squared theta over cosine squared theta. My division changes to multiplication. And when I flip it, what happens? It's cosine squared theta over 1. Now, what do you notice? Perfect. The cosines cancel out, and you're left with just what? Sine squared theta. Good. Very good. Questions at home? How we doing?
Okay.
Perfect. Good, good, good. All right. Now, what do the directions say next to 46 and 48? What did I write? It says to factor. Guys, now we're going to use all of the stuff we know about factoring. On your quiz, if something needs to be factored first, I will say factor, then simplify. That should give you an idea of, okay, wait, I have to use some of my algebra skills here. If I look at number 46, it has secant squared times tangent squared plus secant squared. Before you do anything, since it says factor, let's factor. What does each term have in common? They both have a secant squared x, don't they? So in algebra, we would just divide out what they have in common and we would bring it out in front. So let's do that. All right, I'd write out here, that's my greatest common factor, right? My GCF. What happens now? The secants cancel out, so you're left with tangent squared x plus what? Plus 1. Good. Now, there's a couple things you can do here. All right, I'm going to show you a couple different ways. Where should our eyes go since I have tangent squared x plus 1? Where should we look? Let's look at our Pythagorean identities. What is tangent squared of x plus 1 equal? Secant squared. So can I replace this right here with secant squared of x? Yeah, of course I can. And then I still have a secant squared out here. And I'm multiplying them. When you have the same base and you're multiplying, what do you do to the exponents? You add them. So this is really secant to the 4th power of x. Now, some of you might have gone a different route. You might have said, at this point, you had secant squared x and then tangent squared x plus 1. And you told me that secant is the same as what? 1 over cosine? So I could write it like this, right? And then what did you tell me that tangent was? Secant, right? So then you could simplify and say, well, I have 1 over cosine squared x times 1 over cosine squared of x, right? So then this would become 1 over cosine to the 4th of x, which is the same thing as this. Generally, when we simplify, we don't want any denominators, but I would understand if your thought process went to all sines and cosines. I would take either answer in this case. I mean, there's obviously going to be a lot of partial credit given because this stuff is hard, and I understand that. You're probably going to have like 4 simplifying questions and then 1 where you have to prove. Yes, this is for 4th quarter. Yes. All right, let's look at the next one. A period got this. Let's see if you guys can get it. What were the directions at the very beginning? To factor. Okay, so that means I'm going to be able to factor something. I'm going to be able to factor something. Can you factor the numerator? If it tells you to factor first, that means you need to factor. How can I factor the numerator? Look at you. Cosecant x plus 1, cosecant of x minus 1. That's the difference of perfect squares. Very good. Good job. This is a perfect square. This is a perfect square. It's our difference of perfect squares. If I had x squared minus 4, you guys would tell me x plus 2, x minus 2. Same concept. Because it said to factor first, you knew that was the hint of what to do. So now what can I do? Cancel this and cancel this. Good. So I'm left with the cosecant x plus 1. Can I change cosecant into something? What's cosecant the same as? 1 over sine. Okay, if you guys went one step and said this was 1 over sine, I would accept that. That in red, that's the more correct answer because simplified means it doesn't have any denominators or anything like that, if you can. But I understand if you guys went one step further to go to sine and cosine. So I would take either one of those. Good job. Very good job. More is on it. All right, so how do we feel? The stuff at the top here with the X, the Y, and the R, that's old stuff. We've already done that. That's not going to be on your quiz. The only thing on your quiz is just simplifying and verifying. That is it. So right now, you should be able to turn this in or by the end of the period to get a free homework 100. But I want you guys at home and in here, 7.1 practice part 2. All right. You guys are going to have to do the 7.1 practice part 2. It's going to be due Wednesday morning. I will go through every single one of them like I am now. And I'm going to let you guys ask questions. We can go through different things. That's going to be our quiz review. This video and then the next video that we do on Wednesday. So I'm going to do, A period said that this one looked the hardest. So, okay, fine, let's do this one. What I want to bring to your attention, guys, all of the problems that I give you should not be more than 4 steps. All right, I'm not giving you any of the ones that we gave in pre-cal that were 6 and 7 steps and turning. I'm not going to do that. All right, this is a very hard concept, and we're going to try and keep it as basic as possible. So if you're getting to where you're doing a lot of extra things, we might want to take a step back and just take a break. So let's look at number 55 on this proving. All right, first thing we do is we say, okay, which side looks harder? Left-hand side or the right-hand side? Which denominator looks more complicated? The one on the left, because there's 2 terms instead of 1. So I told you guys, there's not a lot of always do it this way. But when you have a denominator, like we do here on the left-hand side, that has 2 terms, but it's not squared, right? That's not a Pythagorean identity. It's close to 1, but it's not 1. So I want to get rid of that denominator. How do I get rid of 1 minus the cosine of x? What do I multiply the bottom by? What's the opposite of 1 minus? 1 plus, all right? We're going to multiply by the conjugate. So 1 plus cosine of x. What you do to the bottom, you do to the top. So I'm going to just leave the numerator like it is. I'm just going to write sine of x times 1 plus cosine. Because remember, we're trying to simplify, so we don't want to make things more complicated. Just leave them separated. Now let's FOIL the bottom. What is 1 times 1? 1. What is 1 times negative cosine of x? Negative cosine x. What's cosine of x times positive 1? Plus cosine of x. So what's going to happen with those 2 things? They're going to cancel. So then I have cosine times negative cosine gives me minus cosine squared x. Is that one of those trig identities that we've talked about 500 times? Yes. What is 1 minus the cosine of x the same as? Good, sine squared. And I'm just going to leave the top like it was. Sine x times 1 plus cosine. Can I do anything else? I have 1 sine x on the top, and I have 2 on the bottom. Yeah, I can cross one of them out, right? I can cross 1 out here, and I can cross 1 out here. So I'm left with 1 plus the cosine of x over the sine of x. Not really anything else I can do there. That's not a Pythagorean identity. Sines and cosines are our most basic functions. So let's move over to the right and see what we can do. Oh wait, what did we just do? We proved it. 1 plus cosine x over the sine of x. They are equal to each other. How many steps did that take, guys? Yeah. Now, if you took a different route, right, there's going to be some where you're going to see some different things, and some of you might see it one way or another. You might have an extra step here and there. But if you're doing a proof like this and you end up with 9 different steps, then you did something wrong. I'm not going to give you guys anything that's that extremely complicated. What you need to understand is that everything that I have here in red, that is your answer. That is your work. That's what I'm looking for. This bottom step that just says the left-hand side equals the right-hand side, that's good, and that's the way it should be. But just because you write that doesn't mean that you got the problem right. Right? There's lots of steps to get there, so we have to make sure that we are going in that direction. Does everybody understand?
So when you get to like the basic of the sine, cosine, you know that you can't do anything else with it?
And then I would just go to the other side and say, okay, what else could I do? If you end up with a fraction, like if you get to the end, if you're simplifying and you end up at the end like 1 over, if you end up, say, with 1 over sine of x, how can I simplify that a little more so it doesn't have a denominator? It would be what? Cosecant, yeah. You could write it as cosecant x. See, it's more simplified, just looks better. This is just a different example, guys. As far as the practice that I want you to turn in, the top ones, like 7 through 25, we're not doing those. That's from last test. We do things differently in pre-cal, so I just use this practice because I think it's a good one. So don't worry about the top ones, the sine, cosine, y over r, all that. I just want the simplified ones. Make sense? Okay, I'm going to upload this now.